Hi, I'll talk about the arithmetic of time. We're going to look at an example. There is a swimming pool that is 25 meters long, and a girl swims for 1.6 kilometers. Right, so that's the pool. The girl. Question: how many lengths did the girl swim? So the girl swims the length of the pool 25 meters, and she swim back another length, another 25 meters, and she swim forward again and back and forward, and she keeps swimming until the total distance is 1.6 kilometers. So the question is, how many lengths did she swim? So the way to do this is to take 1.6 kilometers divided by 25 meters. Now the important thing here to be careful of is that when we divide two quantities, the quantities means things like that we can measure, like time, length, weight, and so on. The thing to be careful of is that the units can be different, like meters and kilometers. And for example, 1 kilometer is actually 1,000 meters. So before we divide, it is very important that we must convert them to the same units. For example, because 1 kilometer is 1,000 meters, so 1.6 kilometers would be 1.6 times 1,000 equals to 1,600 meters. So now that we have converted to the same unit as the length of the pool, we can just divide directly. So I would take 1,600 divided by 25. Of course, you can just press the calculator, but sometimes for simple numbers like this, there are very quick way to do it by hand or even mentally. And the way to do this quickly is to notice that 25, we know that 25 times 4 is 100. That's a good thing to remember. And notice that there are two zeros here, just like 100. So let's think of this 1,600 as 16 times 100 divided by 25. Alright, then we can divide the bottom by 25 and divide the 100 by 25 to give 4. Right, and once we have 4 and 16, okay, that gives 64. Now that's also a quick thing to remember, a useful thing to remember, that 4 times 16 is 64. Now the way to be familiar with this is to think about how we can write 64 as a product of some factors. For example, 64 is also a square number. It is 8 times 8. Alright, so we get that from the times table. Or it can be 4 times 4 times 4. Right, so it's also a cube number. And because it's 4 times 4 times 4, we know that 4 times 4 is 16. So 16 times 4 must be 64. So these are some examples of products that really helps in sums like that if we have remembered them. Right. The next question, she swims for 1¼ hours. And she finished swimming at 11:05 at this time. Okay. Question. What time did she start swimming? So she starts swimming at a certain time. She swim for 1¼ hours and stop. And when she stopped, the time is 11:05. So that means that she started swimming 1¼ hours before 11:05. So in a way, like the example just now that has different units for the length, here we kind of have different units of the time. So this is in hours and minutes, and this is in just hours. So what we need to do is to convert that also to hours and minutes, or we can convert that minutes to a fraction of an hour as well. But this might be easier because fractions are usually more complicated to calculate. So 1¼ hours, and so in 1 hour there are 60 minutes. So in a quarter of an hour there are 60 divided by 4, and that's 15 minutes. So this is 1 hour and 15 minutes. So what time is it when it's 1 hour and 15 minutes before the 11:05? Now the quick way to do it mentally would be to think, right, 11:05, so 1 hour before, if I represent that by minus 1 hour, is 10:05. Okay, that's 1 hour before. How about 15 minutes before? Okay, let's go 5 minutes before first. If it's 5 minutes before, it is 10 o'clock. And then if it is 10 more minutes before, it should be 9:50. So you can do this mentally and you get the answer of 0950. So that's a quick way to do it. Now to actually write it out by calculating it like a sum might actually be a little more difficult, because if we need to subtract that from 1 hour, or we need to subtract 1 hour and 15 minutes from that, we need to be careful of the 60-minute to 1 hour conversion. Right, so usually for sums here, simple sums like that, it is enough just to do it either mentally or write down a few steps as we backtrack the time. The next question is to find the average speed. So we know that she swam 1.6 kilometers and she took 1¼ hours to swim this distance. So the question is, what is the speed? Right. Now speed, the formula for speed that we must remember is distance divided by time. So to calculate the speed, we must take 1.6 kilometers and divide by 1¼ 1.6 divided by 1¼ So to divide or multiply fractions, if the fraction is a mixed number with a fraction part and a whole number part, we must convert it to just fraction. That means just a number over a number. So this would be 1.6 divided by, so 1 1/4 would be 4 times 1, which is 4, plus 1, which is 5. That's how we do it. 1.6 divided by 5/4. And then we convert the divide to a times by turning the fraction upside down. So that gives 1.6 times 4 over 5. Right, so that's that. Now, of course, you can use a calculator to do it, but I'll just quickly show how I would do it by hand and mentally. So this skill is always useful when doing sums. So now I have this. Now, how do I turn that into the answer? Right, I can turn the fraction into a decimal, so that's 1.6 times 0.8. Okay, now 8 times 16. I can do a quick long multiplication, but I would do it this way. I would ignore the decimal places first, and the 16 here, I think about it as 2 times 8. Alright, and I know that 8 times 8 is 64, because that's from the times table. Then if I take 64 times 2, 64 times 2, alright, so the 4 times 2 is 8, and the 6 times 2 is 12, so that's 64 times 8. Now I look at the decimal points. I have 1 and 2 decimal places, so I go 1, 2, and I put a dot there. So the answer is 1.28 kilometers per hour. Right, so that's the answer for this question. We will continue with some more questions on numbers. Now in this question, we are given this number 8 cubed. So we are given also this expression 2 to the power of k. Now we are told that k is a number, it's an unknown number. And the question is, I want to write 8 to the power of 3 in this form. That means I want to write 8 to the power of 3 as 2 to the power of something. So what is that thing? What is k? So that means the question is simply 2 to the power of what is equal to 8 cubed? That's the question. Right. So the way to do that is to look at the 8 and look at the 2 and think of the connection. So we need to, we can write the number 8 itself in terms of products of 2. So 8 would be 2 times 2 times 2. Okay, and 8 cubed we know is 8 times 8 times 8 times 8. So you can imagine each of the the 3 factors of 2 going to each of the 8. Alright, for each 8 we have 3 factors of 2. So since you have 3 factors of 8, there will altogether be 9 factors of 2. So this should be equal to 2 to the power of 9. So therefore, k is equal to 9. Okay, so that's the direct way to do it. You just write out all the factors of each of these 8 and 8 cubed, and then you compare, you count the total number of factors of 2 and you compare the powers 9 and k, and so k must be the same as 9. Now there's a quicker way to do it, but as you get familiar with the powers, you're dealing with powers like that. And a quick way to do it is, if I start from 8 cubed, because I know that 8 is 2 cubed, I replace 8 by a 2 cubed. Okay, now when I do that, I need to put a bracket around it before I add in the original cubed. Now the reason why a bracket is needed is because I'm writing 8 as some other, in another way, alright? And this other way involves having a cube, that means having some sort of calculations. Now it is very important to remember that the calculations that happen in here, that will give the 8 here, we have to do that calculation first before we deal with the powers, the original power of 3. So because of that, it is always safer to put a bracket there to make sure that whatever we do, the calculations inside must come first before we do the calculations using the 3 there. So we put a bracket there. Now, and when you learn about the rules for powers, you will know that if you have a number to some power and then that number to another power, then it is the same as 2 to the power of 3 times 3. That means that we can multiply the two powers together. Okay, if you are taking the powers one after another. And, oh, that's a 3 there. And then you'll see that 3 times 3 is 9. So using this way, you also get the answer, that k is equal to 9. So you can do it either way. But this way will be quick once you are familiar with calculating the powers. Let's look at this sum. We need to calculate this expression. So we have lots of times and powers and minus and fractions. So everything is here. So what must we do? Right. In the first step, we notice that at the top, at the numerator, we have two products, alright, this one and this one, and we have to subtract them. Now the important thing to remember is that when you have a times, you must do the times first before you do the minus. So because of that, because we must do the times first, you can think of this product and this product, you can think of them as two numbers at first, two separate numbers. So you must minus those two numbers. Right. Now, and if you look at those two numbers, you see that they are products, there's multiplication sign there. You see that they have common factors. Alright, the 2 and 2 there, and the 9 and the 3 there. And if there are common factors, we can take them out of a bracket. We can make a bracket and take those factors out of a bracket. Now, this is what I mean. Let me write down the bottom first. So that's that. Now I can make a bracket. Right? And I can take the common factors out of the bracket. So the common factors would be 3, alright, because 9 can be 3 times 3. So one common factor is the 3. The next common factor is the 2. Now, but it's not just 2, it's more complicated. It's 2 to the power of 10. Okay, that's 2 to the power of 12. So what is the common factor? To understand this, we can think of the 2 as 2 to the power of 10 times 2 to the power of 2. Okay, so let me write this out here again. I'm saying that 2 to the power of 10 times 2 to the power of 2 is actually equal to 2. If I calculate the two powers like this, if I have the same number at the base of the two powers, that means at the lower part of the two powers, I can add the powers. So this is actually 10 plus 2. Alright, which is 10 to the power of 12. And the reason why we can add the powers is because, say, 2 to the power of 10 simply means we have 10 factors of 2 multiplied together. And that means 2 squared means we have 2 factors of 2. So when you multiply the whole lot together, you get 10 plus 2, 12 factors of 2. So that's the way to understand it. And the reason why I want to split the 2 to the power of 12 into 2 to the power of 10 times 2 to the power times 2 squared is because I also have a 2 to the power of 10 there. And if I split it up this way, it becomes obvious that 2 to the power of 10 is a common factor. I can take that out. So times 2 to the power of 10 times the bracket. So if I have taken out the factors of 3 from there, from the 9, I would have a factor of 3 left, because 9 is 3 times 3. And if I've taken out 2 to the power of 10 from 2 to the power of 12, then I will have a 2 squared. Now, for the other products, I would have taken a 3 out, and I would have taken a 2 to the power of 10 out. So there's nothing left. Now, when that happens, it's tempting to write a 0 there, because there's nothing left. But we must be very careful. We are talking about factors, alright? So what is left here should be some number that would multiply by the numbers outside the bracket to give you the original term. And of course, when we're talking about multiplying, it has to be 1, because 1 times a number is the same number. So be careful when we are doing multiplying and cancelling of fractions. So we get a 1 there, and then we insert the minus sign in between. So that's what we have. Now that seems like a lot of work. So let's see if it helps. See if we can now actually calculate this. Now, what we see here is an expression that does not really look a lot simpler. In fact, we have actually added in a bracket, and it actually looks more complicated. Now, but when doing calculations like that, the way to do it is to think of the whole bracket as a single number. Now that's always difficult to do, because bracket usually means that there are a few numbers inside. It usually looks like something big with many numbers inside. So it's hard to think of that whole bracket as actually just one number. But think of it as, if it is a bracket, you have to do the calculations in the bracket first, and if you do that, you end up with an answer which is just a number. Okay, so if you think of it that way, you can imagine the whole bracket as a single number. So what we have here is number times number times number. We have 3 numbers at the top. Okay, so 3 numbers multiplied together, and at the bottom we have 2 numbers multiplied together. So we have this fraction with numbers on top, numbers at the bottom, and we can think about cancelling. Alright, we can cancel the same factors from the top and the bottom. So that's what we are going to do. Now, but before that, I must point out that when you do cancelling in a fraction, in the top and the bottom, you can only do cancelling between numbers that are multiplied together. So when you start cancelling, you must think of the whole of the top as numbers multiplied together and the whole of the bottom as numbers multiplied together. So that's why I said that we should think of the whole bracket as one number. For example, I cannot cancel between numbers like the 3 there and the 3 there, because this number 3 has a number next to it which is subtracted, which is a minus. So that's not a times. Alright, if this number is not multiplied by to all the other numbers, then I cannot do cancelling. As long as there is a plus or minus sign next to it, I cannot do cancelling. So I have to think of this whole bracket as a number, then I have a number multiplied by all the other numbers. So the most important thing to note when doing cancelling in fractions is to note that we cannot cancel numbers that have plus or minus sign next to them. But if I think of this as a whole thing as a number, then I can't cancel anything in this bracket directly with the factors in the denominator, but I can look at the other factors. Right, I have a 3 there, and the 3 is multiplied by all the other numbers. Alright, it might look like there's a minus sign there, but since I'm thinking that the whole bracket is a number, so that's just one number times one number times one number. So they are all times together. So the 3 there and the 3 there is a common factor, so I can divide, I can cancel them. Alright, and again, I should mention that when you cancel 2 numbers in a fraction, you're really dividing them by the same number. So I'm dividing the 3 there by 3, and the answer is 1. Dividing the 3 there by 3, and the answer is 1. So I'm actually replacing the 3 by the 1. I'm not actually cancelling that number so that that number becomes 0. Alright, when I cancel the number, I'm actually dividing it by itself, in this case, so that it becomes a 1 and not 0. So the 3 there is replaced by a 1, 3 there replaced by a 1. Right, now I have a 2 to the power of 8 there and 2 to the power of 10 there. I can use the same method as before. I can think of the 2 to the power of 10 as, say, 2 to the power of 8 times 2 to the power of 2. Right, because I can, if I count the number of factors of 2 there and there, it's the same, because there are 8 factors of 2 plus 2 factors of 2, that gives 10 factors of 2. So if I think of this as having 10 factors of 2 and that as having 8, I can cancel out 8 of the factors of 2, or I can say I can divide the top and the bottom by 2 to the power of 8. So if I do that, that becomes 1 and that becomes 2 squared. Alright, because there are 10 factors of 2, if I divide by 8 factors of 2, I'll be left with 2 factors of 2. So that's what I have left, 2 squared. Now, you can see that the whole thing starts to simplify. At the bottom is just 1 times 1. That's 1. When you divide by 1, you get the same thing. So the bottom is now gone. At the top, most of the factors are gone except for the 2 squared and the bracket. Let's write that out. Now I have a 2 squared times 3 times 2 squared minus 1. See, it's a lot simpler now. We have no more fractions. And what remains then is to calculate the answer. Of course, we'll start with the bracket, and in the bracket we'll start with the times before we do the minus. So 3 times 2 squared. 2 squared is 4. 4 times 3 is 12. Alright, 12 minus 1 is 11. So the bracket becomes 11. 2 squared is 4. So I get 4 times 11. So the answer is 44. We'll stop here.